Hello everyone. In my last lecture I have explained the hybridization of methane, ethylene and acetylene. The different kind of bonds I have explained in methane, ethylene and acetylene. How the bonds are formed, what are the types, how many types of pi and sigma bonds are there, I have explained. In this lecture I want to show you the models of methane, ethylene and ethane, that means acetylene. And this is my methane. You can see this is a tetrahedron, and this structure is obtained by methane due to the hybridization of the central atom carbon. Carbon, when comes to form bonds with these four hydrogen atoms, it is first hybridized into sp3 hybridization, and the four sp3 hybridized orbitals, when collide through their head with the 1s orbital of this hydrogen atom, these four single bonds are formed. Right? These single bonds are called sigma bonds. Why? Because in chemical bonding chapter perhaps you have studied that sigma bond is formed by the head-on collision of the corresponding orbitals. Right? So this sigma bond is formed by the head-on collision of sp3 hybridized orbital of carbon atom, central carbon atom, and 1s orbital of this hydrogen atom. So this is a single bond and it is a sigma bond, right? This is also a single bond and it is also a sigma bond. This is also a sigma bond and this is also a sigma bond. There are four sigma bonds in methane, and all these sigma bonds are formed by the head-on collision of sp3 hybridized orbital of the central atom and 1s orbital of the respective hydrogen atoms that comes in that direction of that sp3 hybridized orbital. Right? This is a perfect tetrahedron. Four hydrogen atoms are placed on the four corners of the tetrahedron, and in the center of the tetrahedron, in this place, the central atom carbon is present. Right? When it comes to ethylene, the model becomes like this. Here you can see, let me put it out. Okay. So when carbon atom gets sp2 hybridized, then it becomes like this. That means it is planar. It becomes planar like this, right? This is one sp2 hybridized carbon atom. This is another sp2 hybridized carbon atom. When these two sp2 hybridized carbon atoms come together, they form bonds, right? This is their sp2 hybridized orbital, and this is another sp2 hybridized orbital. Okay, so when this 1s orbital of hydrogen atom comes to this sp2 hybridized orbital of this carbon atom, head-on collision takes place and this sigma bond is formed. This is one sp2 hybridized orbital of this carbon atom, right? Okay, so if this sp2 hybridized orbital of this carbon atom comes along to the sp2 hybridized orbital of this carbon atom, then this bond is formed. This is a sigma bond, right, between these two sp2 hybridized carbon atom, and this sigma bond is formed by the head-on collision of two sp2 hybridized orbitals of these two carbon atoms. Okay. Now the remaining pz orbital of this carbon atom and the remaining pz orbital of this carbon atom, as they have one electron each, so they collide sidewise, and form pi bond, right? So the pi bond, I can make the pi bond like this. Okay, so I have made the pi bond. Okay. This is the pi bond, this is sigma bond, and this is pi bond, right? So these two double bonds are present between these two carbon atoms, right? And this pi bond is formed by the sidewise collision of the two pz orbital. Okay. Now you can see these two hydrogen atoms that is attached with this carbon atom, and these two hydrogen atoms that is attached with this carbon atom lie on the same plane, but this pi bond lie on different plane in ethylene, right? In ethylene, you can see this. Okay, these two planes are different. Okay, now you can see when the pi bond is formed, when this pi bond is formed like this, when the single bond was present, then the distance between the two carbon atoms was large. But when this pi bond is formed, you can easily see that the distance between the two carbon atoms become less than earlier. That means when double bond is formed between two carbon atoms, the distance between the two carbon atoms become lesser than the single bond, right? Okay. Now this is acetylene. Okay. In this case, we can see this carbon atom, and this carbon atom is sp hybridized. This is the sp hybridized orbital which collide with 1s orbital of this hydrogen atom through their head, and this sigma bond is formed, right? And this sigma bond is also formed by the head-on collision of sp hybridized orbital of this carbon atom and 1s orbital of this hydrogen atom. This single bond is formed. Okay. When if I open this is a sigma bond, and this sigma bond is formed by the head-on collision of sp hybridized orbital of this carbon atom and sp hybridized orbital of this carbon atom. There are two remaining orbitals of each of the carbon atoms, remaining p orbitals, right? One py and one pz. Each py and pz orbital of each carbon atom have single electrons. So when they collide sidewise, they form pi bond. This is one pi bond. When this one pi bond is formed, then the two carbon atoms comes closer. When again the second pi bond is formed, you can see that the two carbon atoms come far closer. That means when triple bond is formed between two carbon atoms or anywhere, the distance between the corresponding atoms becomes lesser than double bond or single bond, right? So this is the structure of acetylene, and you can see the structure of acetylene is linear. This angle is 180-degree angle, and in ethylene you can see this angle is 120-degree angle, and this angle will be 120-degree angle, right? So this is the simple molecules in organic chemistry, and in organic chemistry we will study the molecules by forming these types of models. Hope this video is being able to help you to understand the models of molecules, methane, ethane, ethylene and acetylene, and in this way organic chemistry will be very easy for you to understand, and all the reactions will be very easy for you to understand. Thank you so much for watching.